Hello everyone, this is Veni Maditati. In this video, we are going to learn about vectors. I have divided this entire chapter into 7 subparts. Now, coming to the first part, vector. What is meant by vector? A quantity which have both magnitude as well as direction is said to be vector. For example, let us say a bar, which is equal to 2I cap. Here 2 is the magnitude and I represents the direction. It means it is in this direction. So 2I cap. A quantity which is having both magnitude and direction is said to be a vector. Vector is used to represent the physical quantities that cannot be represented by a single number alone. If we simply say 2, then 2 is not a vector. But 2I cap, which represents magnitude as well as direction, is said to be a vector. For example, displacement, velocity, acceleration, force, etc. Example, if we say a car is displaced 2 meter in the direction of east, here we are representing 2 meter. Here 2 is a magnitude and in the direction of east, it means we are representing both the magnitude and as well as the direction. Such quantity is said to be a vector quantity. And now coming to scalar quantity, vector quantity, and we are going to learn their differences. Scalar quantity is the one which is having only magnitude. For example, let us say I have a mangoes of 4 kg. Here we say it simply by a number, that is 4 kg. It doesn't have any specific direction. Such a quantity is said to be a scalar quantity. It have only magnitude and it follows simple algebraic addition. It means we can add them simply. For example, 2 kg plus 4 kg, which is equal to 6 kg. And it can be changed by changing only its value. If we change the number, then only this quantity will be changed. For example, from 2 kg to 4 kg. Here what is changing? Only number is changing. An example for these scalar quantities are speed, time, mass, volume, density, current, and so on. Now coming to vector quantity. Vector quantity is the one as we have discussed here. It have both magnitude and direction. It follows triangle law of vector addition. We are going to discuss this detail later. And changed by only change in magnitude, either by changing magnitude. For example, a bar is equal to 2I cap or either a bar is equal to 4I cap. Here the vector is changing by changing its magnitude or direction. For example, if we say a bar is equal to 2I cap and let us say another vector a bar is equal to 2j cap. Here the direction is changing, so the vector is also changing. Or by changing the both magnitude and direction. For example, let us say a bar is equal to 4I cap and then b bar is equal to 8j cap. Here the both magnitude and direction both are changing. Such type of quantities are said to be vector quantity. And then examples for vector quantity are force, velocity, current density, torque, etc. And also this displacement, velocity, acceleration and force also comes under vector quantity. Now coming to properties of vectors. In a vector, the positive and negative sign indicate only the direction. For example, there is a force of 8 Newton and minus 8 Newton. Here the magnitude is same, only there was a change in direction. It means, let us suppose there is a block of mass m and a force of 8 Newton is applied. If 8 Newton is in this direction, then your minus 8 Newton will be in opposite direction. So in a vector, positive and negative sign indicates only the direction. It is of same magnitude of force but in opposite direction. And now coming to angle between vector. When two vectors are placed either head to head or tail to tail. Here, let us say this is a vector a bar and it is a vector b bar. Now, either these two vectors can be placed by head to head. The head of a bar and head of b bar are tail to tail, like this. In either of these cases, the smaller angle between the vector is said to be the angle between the vector. Let us see here. This is a vector a bar and this is a vector b bar. And the angle between these two vectors, this is alpha. We don't say this, we don't consider this as an angle between the vector, because only we consider when there are two vectors placed by head to head or tail to tail, the smaller angle is only considered as the angle between the vector. So as this is the smaller angle, we consider only alpha as the angle between the vector but not beta. And now coming to the next point, vector can be shifted parallel to itself by keeping magnitude and direction itself, direction fixed. For example, let us say this is your a bar, this is your b bar. Now you can shift this vector parallelly. This will be also equal to a bar by keeping its magnitude and direction fixed. Here the direction of this and this is same and this both are parallel. So vector can be shifted parallel to itself by keeping magnitude and direction fixed. And this is an important point to remember. Rotation of vector is not allowed. It will change entire meaning of the vector. So rotation of the vector is not allowed. And here are two important points. All equal vectors are parallel, but all parallel vectors are not said to be equal, and all negative vectors are anti-parallel and not vice versa. All negative vectors are said to be anti-parallel, but all anti-parallel vectors are not said to be negative vectors. These were the parallel vectors and this is anti-parallel vector. Let us see. If this is a bar and this is b bar, then your minus b bar will be of same magnitude but in opposite direction to that of b bar. If the angle between this is theta, as we know this entire one is 180 degree, this will become 180 minus theta. If your angle between a bar and b bar is theta, then your angle between a bar and minus b bar vector will be equal to 180 minus theta. Now coming to types of vectors. Now coming to equal vector. Equal vector is the one with same magnitude and also the same direction. See, let us say a bar is equal to 2 I cap and let us say b bar is equal to 2 I cap. And this direction were also same and magnitude is also same. So a bar and b bar are said to be equal vector if and only if they have same magnitude and same direction. In that case, the angle between the vector is equal to 0 degree. And now coming to parallel vector. Here the magnitude may or may not be same, but the direction should be remain same. For example, a bar is equal to 2 I cap, b bar is equal to 4 I cap. Let us extend this. In this case, these both vectors are said to be parallel vectors. Here the magnitude may or may not be same, but I cap, that means its direction should remain same. In this case also the angle between the vector is 0 degree. And now coming to opposite or negative vectors. Here the magnitude should be same and the direction should be opposite. That is, in the case of opposite or negative vectors, the angle between the vectors will be equal to 180 Newton. As we have discussed previously, let us suppose a block of mass m is there. Here if a 8 Newton force is acting and in the opposite direction minus 8 Newton force is acting, and of the angle between these two vectors is equal to 180 degree. So in opposite or negative vectors, the magnitude will remain same and the direction will be opposite and theta is equal to 180 degree. And now coming to anti-parallel vector. Here the magnitude may or may not be same, but theta will be equal to 180 degree. Anti-parallel vector is like reverse of that of parallel vector. Let us say a bar is equal to 2 I cap and then b bar is equal to minus 4 I cap. In this case, we say the angle between those vectors will be equal to 180 degree. That means they are opposite, same as similarly as that of opposite or negative vector. And now coming to orthogonal vector. Here magnitude may or may not be same. Let us suppose a bar is equal to 2 I cap and b bar is equal to 4 j cap. Here it is independent of magnitude. Magnitude either remains same or different, but the direction or angle between the vector should be equal to 90 degree. It means the given if the given two vectors are perpendicular, then we say those vectors are orthogonal vectors. Here this orthogonal vectors magnitude may or may not be same, but the direction, that means angle, should be equal to 90 degree. And now coming to zero or null vector, here the magnitude is equal to 0, and we should not say that zero or null vector doesn't have any direction. Doesn't have direction is wrong. It can have any direction. You have to say for zero or null vector it can have any direction. No direction is senseless. Any direction. So zero or null vector consists of the magnitude 0 and direction any direction. And now coming to unit vector. Always you remember unit vector is represented by like this. For example, a cap or b cap, and its magnitude is always equal to 1. And the direction or angle, here we represent this a cap is equal to a bar by magnitude of this a bar. And now coming to components of vector in 2D. This will be, see, this vector topic will be used in every single topic of your physics. It will be helpful for your entire physics. So please learn it from scratch to scratch. You should be clear with every point. And now coming to components of vector in 2D. So effect of vector. Let us say this is a vector a bar, and this is your I cap, and this is your j cap. Now this vector a cap is at an angle of theta with your I cap, that is with this is x axis and this is your y axis. So if we resolve this component, we get ax is equal to, it means this direction of a bar in x, along x, that is equal to ax, which is equal to a cos theta, and ay, which is equal to a sin theta. This is by following the simple Pythagoras theorem. Let us consider this as ax and this as ay. And now from this triangle, it is as your right angle triangle. In this triangle, your sin theta is equal to opposite by hypotenuse. That means sin theta should be equal to ay by hypotenuse, which is equal to a. So your ay is equal to a sin theta. And similarly, we know that cos theta, which is equal to adjacent by hypotenuse. Here your adjacent is ax and your hypotenuse is a. So ax is equal to a cos theta. In this way, you resolve this component. You simply remember as this. See, here theta is with respect to this x-axis. So this will be your a cos theta, and the rest of the one, this will be your a sin theta. So ax is equal to a cos theta and ay is equal to a sin theta. Here you can represent this a bar as ax I cap plus ay j cap, which is a bar is equal to ax is equal to a cos theta and ay is equal to a sin theta. So a bar is equal to a cos theta I cap plus a sin theta j cap. And the magnitude of this resultant vector is represented as a bar is equal to under root of ax square plus ay square. And let us go through another example. This was also same as this example. Here let us say this is a vector b bar, and it is at an angle theta with respect to this y axis. Okay, and here similarly it is also a right angle triangle. And if this is your bx, this will also become your bx. And if this is your by, then this is also your by. And by again applying this Pythagoras theorem, we get bx is equal to b sin theta and by is equal to b cos theta. Or else you can simply remember like this. As this is your b bar and this is theta, this will become as b cos theta, and the rest of the one, this will become your b sin theta. So in this case, bx is equal to b sin theta and by is equal to b cos theta. So b bar is equal to bx I cap plus by j cap. That means b bar is equal to b sin theta I cap plus b cos theta j cap. Here the magnitude of this will become b bar is equal to under root of bx square plus by square. And remember direction. So direction is given by theta is equal to tan inverse of ay by ax in this case, or else in this case theta is equal to tan inverse of bx by by. You simply divide these both. You get as here you have got ax is equal to a cos theta and ay is equal to a sin theta. You simply divide this both. Now ax by ay is equal to cot theta. It means ay by ax will be equal to tan theta. So here theta will be equal to tan inverse of ay by ax. Similarly, in this case your theta will be equal to tan inverse of bx by by. And now coming to rectangular component of a vector in 3D. Here it is in 2D. Here it is in case of 3D. Let us suppose a bar is equal to ax I cap plus ay j cap plus az k cap. And here the magnitude of a bar, which is equal to under root of ax square plus ay square plus az square. Okay. If a vector is making an angle alpha, beta, gamma from x-axis, y-axis and z-axis respectively. This is one of the important point to remember, and you will study this more detail in maths, vector and 3D geometry. There you will get more clarity on this topic. If a vector is making an angle alpha with respect to x-axis, beta, here let us suppose this as a x-axis and this one as your y-axis and this one as your z-axis, and let us suppose a vector a bar is introduced, then this will be your along this is your I cap, this is your j cap and this is your j cap. Along the x direction it is ax, along y it is ay, along z it is az. If a vector, this a bar is making an angle of alpha with this x axis, beta with this y axis and gamma with this z axis respectively, then cos square alpha plus cos square beta plus cos square gamma will be equal to 1. And we know that sine square alpha plus cos square alpha equal to 1. From that we can write cos square alpha is equal to 1 minus sine square alpha. By that we get sine square alpha plus sine square beta plus sine square gamma equal to 2. And now coming to direction cosine. This is also one of the important point to remember. While coming to direction cosine, cos alpha can be written as ax by a. You simply remember these formulas, and cos beta as a y by a and cos gamma as az by a. You will get more clarity while you do vectors in your maths. Now coming to vector addition. This is one of the important one. It is the process of combining two vectors by placing the tail of one vector at the head of the other vector. Simply, let us say here you have a vector a bar and here you have a vector b bar. Now, vector addition in the sense, here you have to place, see, here it is connected to this b bar in such a way, that is, you have to place tail of one vector and head of another vector. If, let us suppose this is your vector, this is your head and this is your tail. So here tail of this vector, tail of this a vector is connected with the head of the b vector. Then your resultant will be as let us consider as a bar is your first vector and b bar is your next vector. Here simply, if you connect either head with tail or tail with head, then the head of the first vector to the tail of the next vector will be your resultant. Or else if we connect here we have connected tail to head. If you connect head to tail, then it will be like if you connect head to tail, then see, in this case if you connect head to tail, then in that case your resultant will be from head of this first vector to the tail of the next vector. This is said to be vector addition. We'll get more clarity next coming to further. Now coming to polygon laws of vector addition. From this you will get more clarity about this vector addition. Start the tail of next vector from the head of the previous vector and so on. In this way we make the vector addition. Let us suppose this is a vector a bar, this is your vector b bar, and this is your vector c bar. See, this is your vector a bar. Now we have to start the tail of the next vector from the head of the previous vector. So we have to start another vector b bar in such a way and another vector c bar in such a way. Now your resultant will be like from the head of your first vector to the tail of the last vector. Head of the first vector to the tail of the last vector will be your resultant. You have to start the tail of the next vector from the head of the previous vector and so on. Let us say here we have three vectors a bar, b bar, and c bar. Now this is your a bar, this is your b bar, and this is your c bar. This is how you connect. Now this head of the first vector to the tail of the last vector, or else tail of the first vector to the head of the third vector. In such way, if we connect, then it will be your resultant vector. So here your resultant r bar is in such a way. Now coming to we will learn the derivation for this polygon law of vector from this triangle law of vector addition. Before going to this triangle of vector addition, I would like to discuss parallelogram law of vector addition. Let us suppose this is your point O. This is a fixed point, and from this, let us say this is your OA bar, which is represented as A bar, and this is your OB, which is equal to B bar, and this is your OC, which is represented as C bar. Now your C bar will be equal to A bar plus B bar. See, let us suppose this as a OA bar. This is your OB bar. Now this is parallel. If we extend it parallelly, if we place it here, and if we place this parallelly here, now a parallelogram OACB is finished. Here, now coming to this parallelogram law, OC bar will be equal to OA bar plus OB bar. You will learn about this parallelogram law of vector detailedly. You have a question on your IP. On the time you will get more clarity. See, let us suppose this is your OA bar and this is your OB bar. If we replace here parallelly with the same magnitude as we have discussed earlier, we can replace this vectors by keeping their direction and their magnitude fixed. Here simply we are replacing this vector here by keeping its direction and magnitude fixed. So here OA bar is replaced here and this is replaced here. Now your parallelogram is finished. According to parallelogram law, you just remember this one and the magnitude of the resultant vector. These were the important one to remember. Now according to the parallelogram law, OC bar is equal to your OA bar plus OB bar, and here the magnitude of the resultant vector, that is C bar, will be equal to under root of A square plus B square plus 2AB cos theta. Here A comma B are the magnitudes of the A bar and then B bar. And then tan alpha, let us suppose this is your angle alpha, so tan alpha will be equal to B sin theta by A plus B cos theta. You need not to know this derivation. It is just enough to remember these formulas. Magnitude of your resultant vector will be under root of A square plus B square plus 2AB cos theta, and then your tan alpha is equal to B sin theta by A plus B cos theta. Now coming to triangle law of vector addition. See, let us suppose a vector A B bar and another vector B C bar. Now your resultant vector will be from your tail of the either from head of the first vector or tail of the first vector to the tail of the first vector, head of the first vector to the tail of the last vector. So this will be your resultant vector in this case. So A B bar, B C bar, and your resultant vector will be A C bar. Now, according to the triangle law of vector addition, AB bar plus BC bar, which is equal to its resultant, that is AC bar. So, AB bar plus BC bar equal to AC bar. It is very important formula to remember. By using this, we can derive the polygon law of vector addition. So, let us suppose a vector AB bar, this is your BC bar, this is your CD bar, this is your DE bar, this is your EF bar, and this is your FG bar. Now you have to find the resultant of this vector. See, simply the resultant of this vector is AZ bar. But how can you say as this resultant is AZ bar? Here is a proof for it. So AB bar plus BC bar plus CD bar plus DE bar plus EF bar plus FG bar. This is what here we have placed. Now, if you join this, here you can see a triangle ABC. Okay. Now, AB bar plus BC bar, which is equal to your AC bar according to this. So, AB bar plus BC bar should be equal to AC bar. And now continue this series again. CD bar plus DE bar plus EF bar plus FZ bar. And then again take the first two vectors. Now, this will be your another triangle, that is your ACD, which is another triangle. So here AC bar plus CD bar, which is again equal to AD bar. So you place simply in the place of this AD bar, and now continue this CD, DE plus EF plus FC. And now AD bar plus DE bar. In this triangle ADE, AD bar plus DE bar is equal to AE bar, which is according to your triangle of vector addition. So you get AE bar plus EF bar plus FC bar. And again you know that in this triangle AE bar plus EF bar is equal to AF bar. So AF bar plus FC bar. We know that in this triangle AF bar plus FZ bar, which will be equal to your AZ bar. In such way, we can say that this resultant is equal to AZ bar. And by using this triangle law, we can derive the polygon law of vector addition. Hope by this you have got a clarity on this vector addition. Now coming to properties of vector addition. See here, first property. This vector addition is a commutative property. For example, if you take two vectors, for any two vectors A bar and B bar, let us suppose A bar is equal to 4i cap and then B bar is equal to 3j cap. Now A bar plus B bar, which is equal to 4i cap plus 3j cap, and B bar plus A bar, which is equal to 3j bar plus 4i bar. This both are same. So this vector addition will follow the commutative property. For any two vectors A bar and B bar, your A bar plus B bar will be equal to B bar plus A bar. And associative property is defined for three vectors. For any three vectors A bar, B bar and C bar, if we add A bar plus B bar and then with C bar, or else if we place A bar as separate and then we add B bar plus C bar, in this case also your answer will be same. For example, let us say here C bar is equal to 8k cap. Okay. Now your A bar plus B bar is 4i plus 3j and your C bar is 8k, which is A bar means 4i cap plus B bar plus C bar, which is 3j cap plus 8k cap. Both are same. It means your vector addition is also obeying associative property. And existence of additive identity. See, here zero vector is known as additive identity. It means, let us say there is a vector x. If we add something to the vector, then again it remains as x only. In which case does it happens? If we add 0 to anything, then it remains same as that of the previous thing. So, zero vector is known as the additive identity. It means A bar plus 0, which is equal to 0 plus A bar, that is equal to A bar. And now existence of additive inverse. It means if we add something to a certain vector, its answer should be become equal to 0. Let us say x bar is a vector. How can it become 0? By subtracting it again with the same quantity. Yes. So negative of a vector is known as its inverse. So for a vector A bar, what is its negative? Minus A bar. So inverse of A bar is, this is called as inverse. Inverse of A bar is given by minus a bar. So a bar plus of minus a bar, which is equal to minus of a bar plus a bar, which is also equal to 0. Here the sum should be equal to 0, and here the sum should remain same. And now coming to vector subtraction. Vector subtraction was also same like as of vector addition. Here in vector addition, if we take a bar plus b bar, in vector subtraction, if we take a bar and minus b bar, we can simply write this as a bar plus of minus b bar. See, a bar minus b bar, this is equal to a bar minus b bar. We can write this a bar minus b bar as a bar plus of minus b bar. Subtraction of a vector b bar from a vector a bar is defined as the addition of vector minus b, that is negative vector of b, to the vector a. See, this example, this is your a bar, this is your b bar. Now your minus b bar is like your opposite vector, same magnitude but in opposite direction. So your a bar minus b bar can be written as a bar plus of minus b bar, and in this case your resultant will be, this is your a bar, this is your b bar. So tail of the first vector to the head of the last vector, this will be your resultant. But here the magnitude will be equal to a square plus under root of a square plus b square minus 2ab cos theta. In vector addition, your resultant will be equal to under root of a square plus b square plus 2ab cos theta. And now coming to component form of vectors. That means if you take a bar is equal to a1i plus a2j plus a3k, and let us suppose another vector b bar as b1i plus b2j plus b3k, then your addition of these two vectors will be addition of their respective components I with I, j with j, and k with k. That is a bar plus b bar equal to a1 plus b1i plus a2 plus b2j plus a3 plus b3k. And subtraction will also remain as same. You subtract the components, respective I component, j component, and k component. So a bar minus b bar equal to a1 minus b1i plus a2 minus b2j plus a3 minus b3k. And now coming to, let us solve few questions here. Find the change in speed and velocity. We know that starting of this topic we have discussed as speed is your scalar quantity. It is independent of the direction. It depends only on the magnitude. What is change in a certain quantity? It means final minus initial. Here v initial which is equal to 10 meter per second, and v final which is equal to 10 meter per second. So here change in speed, magnitude as how far the magnitude remains same, this change in speed will be equal to 0, because final minus initial, 10 minus 10, which is equal to 0. But coming to velocity, velocity is a vector quantity. It means it also depends on the direction. See, if we consider this coordinate axis, this is your x, this is your y, this is your negative x, and this is your negative y. This will be your I cap, this will be your minus I cap, this will your this will be your j cap, and this will be your minus j cap. Here as they were asking the magnitude, this vi, that is v initial, is 10j. This v final is minus 10j. Now what is the magnitude of change in velocity? Final minus initial. It means minus 10j minus 10j. That is minus 20j. And the magnitude of this will be equal to 20 meter per second. Magnitude, it should be always a positive value. And see, here a bar is equal to 0.6 I plus beta j, which is a unit vector. Then we have to find the value of beta. What I have said, what is meant by unit vector? Its magnitude is always equal to 1. See, how can you calculate this magnitude? If let us suppose there is a vector in this like this, a bar is equal to ax I cap plus a y j cap, then your magnitude of this a bar will be equal to under root of ax square plus under root of ay square. So here your magnitude of a is equal to 1. So under root of 0.6 whole square plus under root of x component plus under root of y component should be equal to 1. So 0.6 whole square plus beta square, which is equal to 1. By this you get the beta value as 0.8. And find the angle with which a vector I cap plus j cap plus root to 2k cap makes with x, y, and z axis. We know that a bar, which is equal to under root of x square plus y square plus z square, which is equal to 2. Here ax is equal to 1, ay is equal to 1, az is equal to root 2. Now we have discussed previously that direction cosines, as cos alpha is equal to ax by a, cos beta is equal to ay by a, and cos gamma is equal to az by a. As we know all these values, if we replace here, we get alpha, beta, and then gamma values. Now coming to displacement vector. Let us suppose this is your coordinate axis with your origin O. This is your x axis and this is your y axis. And let us suppose this is a position vector r1 bar, and this is your point P, which is equal to x1, y1, z1, and this is your position vector r2 till this point Q. Here your OQ bar, which is equal to r2, and the coordinates of this Q are x2, y2, and then z2. And now here this will be your resultant first vector, tail of the first vector to the head of the last vector. So this is your resultant r bar. If a particle moves from initial position x1, y1, z1 to the final position x2, y2, z2, the displacement vector r bar is given by, what is displacement? Final minus initial. So r is equal to final x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. That means your displacement vector is here change final minus initial, which can be represented as delta x I cap plus delta y j cap plus delta z k cap. And the magnitude of your displacement vector will be the respective component x square plus component of y square plus component of z square, that is I cap x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. And here is your super duper important question. Let us solve this. Here, coming to the question, Anu moves in east direction at a speed of 6 meter per second, and Shyam moves 30 degree east of north at a speed of 6 meter per second. The magnitude of their relative velocity is, let us suppose Anu, this is your east, this is your west, this is your north, and this is your south. Here Anu is moving in east direction at a speed of 6 meter per second. So velocity of Anu is equal to 6 meter per second. And Shyam moves 30 degree east of north. You have to be aware of this term. In kinematics, we get this type of problems, and we'll get related to this terminology. We'll get more clarity on this terminology while we go to kinematics. So, and Shyam moves 30 degree east of north. That means this will be 30 degree east of north. This will be your velocity of Shyam, which is 6 meter per second. Now we have to find the magnitude of the relative velocity. So for this, we make the relative velocity in x direction, and we find the relative velocity in y direction. And by this we can get the magnitude of the relative velocity. It is so simple now. So relative velocity in x direction. Here we know that if we resolve this component, see, as this is your 30 degree, this will be your 60 degree. So in x direction we get velocity of Anu 6 I cap minus this velocity of Shyam. If we resolve this, this will be your 6 cos 60, and this will be your 6 sin 60. Okay, this will be your 6 sin 60, and this will be your 6 cos 60. So relative velocity on x direction, which is equal to 6i minus 6 cos 60, which is equal to 3i. As we know, the value of cos 60 is equal to 1 by 2. And the relative velocity in y direction, which is simply only, you can write this either as vs cos 30 or vs sin 60. Both are same. Sin 60 is equal to cos 30. So v relative in y direction is equal to 6 cos 30 z cap. By this you get relative velocity in y direction. Now the magnitude, which is equal to your velocity in x direction whole square plus velocity in your y direction whole square. So here your relative velocity will be equal to 3 I cap plus 3 root 3 j cap, and if you find magnitude, you get the answer as 6 meter per second. See how simple is this? And coming to another question, in which of the following combination of 3 force resultant will be 0? There is a condition for this. When will be the resultant equal to 0? Sum of two smaller forces must be greater than or equal to third. In that case, you say the resultant of the 3 force will be equal to 0. Here, the smaller forces, two small forces are 3 Newton and 7 Newton, and the sum of this, which is equal to 10 Newton, as the sum of the two smaller forces, which is greater than or equal to third one. In this case, you in this manner you check for this all options. So option A suits to this. This will be your answer. Sum of two smaller must be greater than or equal to third. In that case, you say the resultant of the three forces will be equal to 0. And now coming to scalar product, which is also said to be dot product. This is also one of the important one in your vectors and your entire physics. Scalar product of two vectors is equal to the product of their magnitudes and the cosine of the smaller angle between them. Let us suppose your vector A bar and this is your vector B bar and this is your smaller angle theta. Now, scalar product, it means dot product. So, dot A bar dot B bar, which is equal to A into B cos theta. Now you may get doubt. How do we get this? So, here this is your A bar, and if you resolve this component of B bar along this A bar, you get B cos theta and B sin theta. So A bar dot B bar is equal to the component of A bar into component of B bar along the direction of A bar. Once again I repeat it, component of A bar into component of B bar along the direction of the A bar, that is A bar dot B bar, which is equal to A into along the component of B bar along the direction of A bar is your B cos theta. So A bar dot B bar is equal to AB cos theta. And now coming to the properties of the scalar product. This scalar product is commutative. That means A bar dot B bar, which is equal to B bar dot A bar. Okay. Let us suppose your A bar is equal to 3I and B bar is equal to 4I. It should be of same direction, na? So A bar into B bar, which is equal to 12, or B bar into A bar, that means 4I into 3I, which is equal to 12. Now coming to distributive. Again, you make your example own and try it. A bar dot B bar plus C bar, which is equal to A bar dot B bar plus A bar dot C bar. Now, scalar product of two perpendicular vectors is 0 because cos 90 is equal to 0. Scalar product of two parallel or anti-parallel vectors will be equal to the product of their magnitudes. It means in case of the parallel vectors, the angle is 0, cos 0 is 1, that is AB. Anti-parallel vector, theta is equal to 180 degrees, so minus AB. It means it is equal to the product of their magnitude. Now let us go through this question. If A bar is equal to and B bar is equal to, then A bar dot B bar, we have to multiply x I with I component, y component and z component respectively. So 4i plus 2j minus 3k dot this. You get 4 into 1 4, 2 into 3 6, minus 3 into minus 2 again 6. So 16. Remember, I cap into I cap is equal to 1, j cap into j cap equal to 1, k cap into k cap is equal to 1. With the same vector, the dot product is equal to 1. And with another different one, the dot product is 0. This is only you have to remember in your entire scalar product. This is what your scalar product is. How easy it is. I cap dot I cap is equal to 1, j cap dot j cap equal to 1, k cap dot k cap is equal to 1. But I cap dot k cap 0, j cap dot I cap 0, k cap dot j cap 0. Now, let us go through another question. A force F bar is equal to this much, displaces a particle through, then find the work done. We know that work done W is equal to F bar dot S bar. this formula will, you will go through this formula in work, power and energy. So product of this force and displacement in the same way, you will get the answer as 42 joule. Hope you are clear with this scalar product. Now coming to another important one, that is your cross product, which is also said to be vector product. Your scalar product, which is also said to be, as we discussed previously, scalar product, which is also said to be dot product. Here cross product, which is also said to be vector product. Now let us suppose this is your vector a bar, this is your vector b bar, and it is inclined with an angle theta. Now cross product will be the sine of the angle. A bar cross B bar is equal to magnitude of A bar into magnitude of B bar into sine theta into n cap. It is also called as vector product. Okay, as we are multiplying here with this n cap, magnitude of the vector is equal to simply this one, A bar, magnitude of A bar dot magnitude of B bar sine theta, and the direction of the vector is your n cap. Here n cap is nothing but your direction of the vector perpendicular to the plane of A bar and B bar, such that it follows right-handed system. I know that you have understood nothing. See, if this is your A bar, this is your B bar, and this will be your n cap, or we can say it as A bar cross B bar. If this is your A bar, this is your B bar, this will be, and these both were inclined at an angle theta, this is what n bar, which is perpendicular to the plane of this A bar and B bar. To this plane A bar and B bar, your n cap is perpendicular now. So we can also say this n cap as A bar cross B bar. Okay, now you have understood a little bit, I think. This cross product is also called as vector product due to this reason. Here you remember, it is reverse to that of this scalar product. In that, I cap dot I cap is equal to 1, but here I cap cross I cap is equal to 0. This is read as cross, not into. Okay, J bar cross J cap cross J cap 0, K cap cross K cap 0, I cap cross J, which is equal to K, and similarly J K I J, like this you get. If you go through this order, I J K, same order, if you go through this I J K in this order, it will be positive. But if you go through reverse order, that means J with I, then your answer will be in negative. Okay, so let us learn how to make cross product. If A bar is equal to A1i plus A2j plus A3k, and B bar is equal to B1i plus B2j plus B3k, and A bar cross B bar, here this is I cap, J cap, K cap, write this as common, I, J, K. Under I, you have to make this respective component A1, this J, A2, this K, A3, here B1, B2, B3. Now A bar cross B bar, which is equal to, as in matrices how you have made for this determinants, in the same way you make here. If we take like this, you have to make I into, you have to close this first row and first column. Yes, here I have written something mistake. Yes, here A bar cross B bar means, see, let your A bar be A1i plus A2j plus A3k, and your B bar be B1i plus B2j plus B3k. Now your A bar cross B bar, see, write this I, J, K, A1, A2, A3, B1, B2, B3. So I into, close this I, corresponding to I, this first row and first column. So A2, B3 minus A3, B2. Now for J, you have to place negative sign. So minus J into. Now close this row and this column. So A1, B3 minus A3, B1. Again here you will get a positive sign. Only in middle you get negative. So minus J, here plus K into. Now close this row and this column. So A1, B2 minus a1 b2 minus a2 b1. In such way you make a scalar product. Let us go through an example. A bar is equal to 4i plus 3j plus 6k, and b bar is equal to 9i plus 6j plus 3k. Okay, now your a bar cross b bar will be, so let us place I, j, k, 4, 3, 6, 4, 3, 6, 9, 6, 3. Now close this. I into 3 3s are 9, minus 6 6 are 36, minus j into this 4 3s are 12, minus 9 6 are 54, plus k into 4 6 are 24, minus 9 3s are 27. And by solving this, you get your scalar product. In such way you calculate a scalar product, cross product. And now coming to this properties, it is not commutative, it is reverse commutative. See, here we have made a bar cross b bar, no? A bar cross b bar. You try b bar cross a bar. While you make b bar cross a bar, you have to place I, j, k. First this 9 6 3 comes at the top and this 4 3 6 goes down. Now you do the same thing, you will get answer with a negative sign. Okay, so it is not commutative, it is reverse commutative. Two vectors a bar and b bar and scalar m. So if this is m is your scalar one, so m times of a bar cross b bar, which is equal to a bar cross m times of b bar, which can also be written as these three are same. Okay, in similar way, if two vectors a bar b bar and two scalars m comma n, this 4 will be same. Just simply remember this. Now coming to distributive property, here also the distributive property will be followed. A bar cross b bar plus c bar, which is equal to a bar cross b bar plus a bar cross c bar. A bar plus b bar cross c bar, which is equal to a bar cross c bar plus b bar cross c bar. A bar cross b bar minus c bar, which is equal to a bar cross b bar minus a bar cross c bar. And now let us make a question of NEET 2022. How simple question they asked here. Force acting on an object F is equal to this much. Position vector R bar is equal to this much. Then you have to find torque. We know that torque tau is equal to R bar cross F bar. So you have to place this R terms I, j, k, R 2, 2, minus 1. For F it is 5, 3, minus 7. And then you simply multiply this. In the same way you will get the torque. And now coming to the last topic, but very important topic, that is Lami's theorem. It is actually, we study this in NLM also, that is your Newton's laws of motion or laws of motion. So for three vectors it is defined when the three vectors are said to be in equilibrium, that is the sum of the net forces are said to be equal to 0. In that case you use Lami's theorem. Let us suppose there is a block of mass m. This is your vector a bar, this is your vector b bar, and this is your vector c bar, and the angle here is alpha and the angle here is beta, and let the angle here will be equal to gamma. Then what does this Lami's theorem says us? See, a bar opposite to this a bar we have angle opposite to the sine angle. You divide with sine of opposite angle to this vector. That means a bar by sine alpha, b bar by, for this opposite angle is your beta, so b bar by sine beta, c by sine gamma. So a by sine alpha equal to b by sine beta is equal to c by sine gamma. Then a bar plus b bar plus c bar equal to 0. This is what your Lami's theorem is. Now here we have a question based on your Lami's theorem. Let us go through this question. As shown in the figure, the tension in horizontal cord, that means this, is 30 Newton. The weight W, this block of weight W, and tension in the string OA, this, in Newton R. We know this Lami's theorem, right? So apply it here. Let draw this clearly here. This is your weight W. Let us suppose the tension in the string horizontal cord T, and let us suppose tension in this OA string is equal to T1. Now you know this angle is 90 degree. Yes. They have mentioned this angle as 30 degree, right? You know, if we draw this like this, these both were perpendicular. That means the angle between these both is 90. So this entire angle will be equal to 90 plus 30, which is 120. And then if this is 90, this is 120, we know that this entire sum should be equal to 360. By this we get this angle as 150. Okay. Now you simply apply this Lami's theorem here. So here 30 by sine 50, which is equal to T1 by opposite to T1, it is 90 degree, right? T1 by sine 90. By this we get the value of T1, and again applying Lami's theorem, W by opposite to this, the angle is 120. So W by sine 120 is equal to 30 by opposite to this, the angle is 150. 30 by sine 150. By this you get the value of W. So you get the value of this weight and tension in the string by this Lami's theorem. This is what your Lami's theorem says. You just simply want to remember this. Force opposite angle. Force divided by sine of the opposite angle. Force divided by the sine of the opposite angle. Okay. This is what your vectors. By this, what your vectors is. By this you have completed your entire vectors from scratch. And if you have any doubts regarding this topic, you can ask me in comment section. And if you want me to discuss more questions, you can also ask me in comments. I will provide it. And for session notes, you can ask me. I will provide it for sure. I will provide a PDF link in description if you ask me in comment section. Thank you for watching my video, and subscribe my channel for more videos. In this video, this will be a super and helpful session for you. I have discussed in a short interval of time each and every point with enough questions. Hope you are clear with these vectors. Thank you for watching, and subscribe my channel for more videos. And don't forget to like, share to your friends. Okay, if you have any doubts, please feel free to ask me in comment section. And once again, thank you for watching, and our next video will be on kinematics, that is motion in a straight line. Okay, thank you for watching.